But if I visualize the losses, I can attack them. So the next pillar now is I can attack them. Right. Number 3 pillar. Let's go elimination. Now, this sounds relatively easy, but it is very difficult. Because if you could have eliminated the losses, you would have done it. Some of you are working in companies that exist already 200 years. In processes there are where all kind of intelligent people have been thinking about, they designed that, they made beautiful machines and so on. So if it was so easy to take out those losses, it would have been done. So what is the difficulty? The difficulty is, and a lot of you probably studied something like mechanical engineering or industrial engineering, we think in technology, right? So we think if we design a beautiful machine, that machine will have a good conversion. And this is not true. I mean, I work a lot in Germany. Some of you have contacts in Germany. The best and beautiful and most well-designed machines I've seen in Germany. And this is actually the strength, and it's also their weakness, because they think that machines, well-designed, will have well-running production, which is not true. It's not about the machine. It's about the combination of the machine and its environment. And the first guy there is the operator. The second one is the maintenance guy. The third one is the process engineer. And the fourth one is the logistic guy. Then we've got some quality people, and so it extends. So this whole system has to work together. So I've seen lousy machines with great teams having super OEEs. The machine was an ugly thing, they modified it, and they kept it running. I've seen excellent machines, beautiful. I mean, as an engineer, I was gripping from how well designed. Lousy OEE, because the whole process around it didn't work. So this is the difficulty. So if you have been studying mechanical engineering or something, they didn't tell you about people. People are very strange kind of machines. I mean, you can't predict them, you can't steer them, they are always doing something else. If you look from that perspective, this is true. And looking from another perspective, you see other things. People actually are more standard than different. I mean, there are 2 kinds, let's say 4 colors. What else? I mean, we are more the same than we are different. We have the same basic software. I can make a murderer from you within 2 minutes. Take your child, you immediately go in murder mode. Right? So this is something that is in the basic software included. So if you know how this basic software of human beings work, you can play with that and you can work with that. So one of the things that I did is I started to study psychology because I got so frustrated that those stupid people didn't do what I wanted, and I was the expert on designing beautiful software, and it was so well designed, and still they didn't do what I wanted. Why is that? After I understood how the basic software of human beings work, I thought, of course, it's completely logic that I do it, because I missed the basic thing. I didn't show attention to those people, and the people just wanted to hear, I see you, I hear you. And at the moment that I knew that, when somebody came and shouted to me and so on, I was not going into my guerrilla mode and shout back. I said, okay, the guy wants to be heard. Okay, he shouted, okay, I've heard you, you're upset. What's going on? And then you immediately see the guy, okay, he's not going to fight back. Obviously, he wants to listen to me. All his managers didn't listen to him. So this is the mechanism. I'm losing my track. We are going to eliminate losses. Again, I write. Rob, this is because it's 8 o'clock and it's only 1 cup of coffee. Okay, so if you're eliminating losses, there are a lot of stories to tell about it, but there are 2-3 critical issues. First of all, always apply the good old PDCA circuit. So don't just shoot from the hip, and especially don't be an engineer. Because if the machine breaks down, it's very easy to put something on it. Yeah? I've seen some guy, I will not name some names, they have a quality problem. What did they do? They designed a beautiful camera system and all kind of technology to solve that problem. Right? So what you're doing now, you're adding complexity to your machine, to try to solve the problem. Now, if you go that route, you're going to figure out why. How does this occur? Now, I'll give you one thing to think about, and that is if you're having quality problems, for example, or maintenance, well, let's take quality problems, and you're running 99.99%. So that means that in 9,999% of it, 9,999 cases, you're running a good product. And at once, one is coming out that is not good. Now, the industrial engineers here, your challenge is design me a machine that does exactly do that. Design me a machine where you can just put on and say, well, produce, say, 99 good products and one wrong, and then 99 good ones and one wrong. And you can even do it at random. Design a machine that does it. So, this is the situation in every factory. Every factory has that type of machines. So how is it possible that you're producing good products and wrong products? There's a reason for that. That's not something like somebody up there decides to. It's not like Haldan and donor. No, there is a reason for it. So if you find out the reason, if you find out the parameters that are causing this one thing not to be good, you now are able to turn off that parameter. So now you have a knob on the machine to just turn on the quality up and down. You need maybe 3 or 4 or 5 of those buttons. If you know where to design the button, you can switch that. So this is a way of thinking. If you think in machine type of things, find out what specifically in this situation was different than in the other situation. If you know that, if you take the time to find this out, you will find out that it is possible to have zero defect productions. I'm trained by Japanese guys, as I told you, and those guys are just not talking about Six Sigma. I mean, Six Sigma, if you would fly a 747 at a Six Sigma level, and that means that 3.4 per year will drop down. That's Six Sigma. So is that good? No. Is 99.99% good? No. If you fly with 99.99, you will drop down 3.5, 4 times a week. So you can't have it. So the eliminate losses process is a PDCA process, and don't think you can do that with experts. I cannot do that for you, and no expert in the world can do it for you. The real experts are, or the real expertise is in the head of a multitude of people. So those people are around the machine and around the product, and they start at it, and they look at the problem. So everybody is looking from a different angle, right? So if I ask you to describe this thing here, let's call this the problem, then you will give me a description. You will give a different description than you. But the only one who could tell you that this is adding 800 by incident was me, because I was at the angle where I could see it. The other ones, all experts here, could not see this. So you need to have 360-degree vision around your problem. And who are the experts here? That are the guys that touch the problem every day. Why? So an operator is in his field an expert. He knows the behavior of the machine in no other way. There is even the designer, even the supplier doesn't know his machine from the perspective of the operator, because he knows when this vibration starts, usually that is going to happen. Nobody else knows that. So you need this expertise. So form teams that are disciplined and multi-visual to the problem, and make them go through the PDCA stage. So this is those Kaizen teams or the quality circles or whatever name you want to give them. We call them small group activities. They are going to go through 8 stages, whatever, plan, do, check, act, and eliminate the losses. Okay, so now I found out what needs to do. So I have my true north. I want to see all the losses. I visualize them. I now know where they are. I'm going to attack them and take out the top 3. I'm going to assign them to teams. The teams are going to work on them, and I'm going to eliminate them. Is my problem now gone? Well, the OEE will go up. So what happens if OEE goes up? If OEE goes up, the machine has more capacity, brings more out, and will lose less product and less money due to the fact that we have all those losses. We eliminate them. But that doesn't mean necessarily that your process is going to improve. In some cases, when the OEE goes up, your problem is going to be only bigger. Because now, more or less, all those machines that are connected in some kind of a value stream, they more or less are balanced and they work with all their problems. Now, one machine is going to have a higher capacity, so that is disturbing actually the process flow because it can go faster, it can bring more output. So usually what you see if you're focusing only on one or two machines is that it is going to disturb your flow.